My name's Ryan. I'm a NASA GLOBE Clouds intern and SatCORPS intern for the summer of 2021, and I'm going to be going over my research on the solar terminator problem. So first up, the solar terminator problem. What is it? So the terminator is also known as the twilight zone, and it's the line that divides the light and the dark side of the Earth. As shown in the figure here, this is the terminator line. And what's the problem with it is that cloud signals from the terminator can be very hard to interpret, and that's due to very low levels of light. It's not completely dark and it's not completely light on this line, so that makes it challenging for satellite retrieval algorithms to accurately detect cloud cover. So how do we solve this? So both the NASA SatCORPS team and the NASA GLOBE Clouds team offered solutions in order to help solve this problem. So what the Globe Observer app allows citizens to do is contribute to different problems that NASA needs help solving. So for this specific one, during the terminator hour, citizens could go outside and they would be prompted to take photos of the clouds from the 4 cardinal directions as well as up and down, and they would report variables such as cloud cover, sky visibility, and cloud type. And this data will then allow us to validate the new NASA SatCORPS algorithm. So how do we validate cloud detection? So we know that there is false cloud detection, but how do we validate it's there? And then how would we validate this new algorithm that we're trying to solve it with? So we can use human observations in order to validate what we're seeing from the satellites. So now I wanted to give an example of the solar terminator problem. So this graph on the right here, we're looking at the Sahara Desert, and what it is essentially showing is the monthly mean cloud fraction from hourly analyses. So why the Sahara Desert is so good is because usually there's very low cloud cover, if any, over this area. So when the terminator is passing through, it'll bring with it a lot of false cloud detection. So it'll be easier to see because normally it's clear skies over the Sahara Desert. So as you can see in this area, there are these sort of lines of light blue, like light blue diagonal lines as they cross through the purplish bluish area. And what this is when the terminator is passing through the Sahara Desert. So I mentioned this is an hourly analysis. So essentially this line here would be the first hour, the next would be the second and third. And this really shows that the terminator line is bringing with it approximately like a third of false cloud detection through the Sahara Desert. Now I wanted to talk about an example in the United States. So the reason we're looking at this is because a citizen scientist alerted us of this case. The citizen scientist location is in the center of Oklahoma, represented by the pink square. And on the left, you have the RGB animation, and on the right is the cloud mask product from SatCORPS. And as the terminator comes through, you're going to notice in the Midwest a ton of false cloud detection, because again, blue means clouds and green is clear. And you can see a lot of false cloud detection in the Midwest in our cloud mask here. We're in the RGB animation, there doesn't appear to be much of any. And what really reassures us that this is false cloud detection is then as the terminator passes through, it clears up again. So you're going to see as the terminator line passes through, the Midwest then clears up and is back to normal. So first, I know I've talked a lot about citizen observations, and some of you might not even know what that is or what a citizen observation consists of. So I wanted to give an example, and this right here is what a citizen would provide us with. So they're taking photos of the 4 cardinal directions, north, south, east, west, as well as up and down. So they provide us these photos in order for us to determine what the cloud cover is, and they report it as well. So this citizen, if you see in this green box down here, they reported few or less than 10% of cloud cover. And they also reported altostratus clouds. So then the citizen is matched up with a geostationary satellite. In this case, it's going to be GOES 16. GOES 16 is one of the satellites that covers North America. So this is the same one we looked at previous. The citizen is in the middle of Oklahoma. And this is what they see when their observation is matched with the geostationary satellite. They get a visible image as well as the infrared. And in a visible image, down here, you can see sort of a cloud sheet south of them, as well as some scattered clouds north. But where they're at, there doesn't appear to be much of anything. And then the infrared image sort of backs that up. You can see scattered clouds here or there, but there definitely isn't a lot if they are present. And then what the algorithm outputted for the total cloud cover was 98.47%, which is insanely high. Our citizens said that there was less than 10% cloud coverage where they were looking. And another thing that's sort of like, I initially thought that, okay, maybe there is 98% of cloud cover, and maybe it's just in the higher altitudes. Maybe you can't see it from the citizen's photo. But if you take a look at cloud cover based off of altitude, most of it is in the low altitudes. Approximately 95% of it is, which would mean they're easier clouds to see from the photos we're provided. And as you can see, I definitely don't think there's 95% low altitude cloud coverage. So then with all this information, we would then generate products that display this case. We already looked at this. This is the same case we looked at previously. But just to reiterate, as the cloud mask animation progresses and the Terminator line passes over our citizen, it brings with it a band of false cloud detection. So right here is a great example. The whole Midwest essentially is covered with this false cloud detection. And the RGB image, you don't see a whole lot of clouds. There are some present, but just not to the extent our algorithm is reporting. So now I'm going to get into what the new cloud mask looks like with our machine learning algorithm. So initially, where our citizen is located in the middle of Oklahoma, there's a 99.53% cloud cover where they're at. And with the new algorithm, it didn't clear it up massively. It's still 94.39%. But that could be because of a lot of factors. The algorithm might not be perfect as of now, but also there could be clouds that we're just not seeing in the citizen's photo, and it's hard to tell at sometimes. But nonetheless, if we look at this new animation, the one on the far right here is the new machine learning algorithm, where the one in the middle is our old algorithm that we've been looking at. So as the Terminator line is passing through the Midwest, here's a great example. You see the whole Midwest covered with our older algorithm. And in the new machine learning algorithm, you don't see that. And you see a lot more natural clouds being detected. And some of this could be false cloud detection, but at the same time, there are clouds present. And while this new algorithm isn't 100% perfect, we're still working to refine it. And it is considerably better than the old cloud mask product. So this next case we're looking at is in southern Michigan. And with our old algorithm, it reported a cloud cover of 43.75%. And with the new machine learning algorithm, it cleared it up completely, and there's now 0% cloud cover. So the system is located where this pink square is, southern Michigan. And this is a sunrise case. So as the Terminator approaches, you can see in our older algorithm, this sort of faint line, which is all the false cloud detection. And as it approaches closer, it becomes more visible. And you can see this unnatural diagonal line that's essentially looks like a staircase. And in our new machine learning algorithm, our new cloud mask, you don't see that line of false cloud detection at all. It completely cleared all of the false cloud detection where our citizen's at. And as it continually progresses throughout the globe, you see, this is a great example. You see, even in the Midwest, there's a lot of false cloud detection, where in our new example, you don't have any. So the conclusions that I came to from validating this new algorithm is that the new algorithm does improve the ability to detect clouds from satellites during the Terminator compared with traditional methods. And another thing is that GLOBE citizen scientists, their observations, especially the ones in the IOP, that were just meant for Terminator observations, they were very useful for identifying satellite cloud detection problems. And another thing I did note is that the larger GLOBE dataset did contain greater inaccuracies than the IOP dataset. And that's just interesting to note going forward when we do use citizen scientist data to solve problems like this. Lastly, one of the pluses of working on the Terminator problem is you look at sunset and sunrise photos essentially all day. So these are just some of the cool photos I thought from going through them. One really cool thing about the GLOBE project is that everyone from all around the world is trying to solve a similar problem in a sense. So you have observations from like India, from Florida to construction sites, people on airplanes, and like this top photo here is from a schoolyard where students were making observations. So it's nice to be having all these people from around the world sort of contribute to the same problem. And it's really cool what everyone can do when we sort of work together in order to help solve a similar problem.